Welcome everybody. Let's complete the lesson. We started in the previous class once we say like each one mole is represented by 6.02 times 10 to the power 23 particle or atom, molecule, or even ions. We want to express the moles furthermore by another law is represented by, let's say, the mass of an element, the mass of a compound that you have over something called molar mass. But before we go deep on these things, we have to understand what is the meaning of the molar mass at this point. If we take 1 mole, let's say, of iron, 1 mole of water, 1 mole of, let's say, zinc, and we talk these moles on balance, like separately on balance. Since we have 1 mole of each, do you expect to have the same mass? The answer is, it depends. So we have to look at where does the mass of atoms or elements or molecules come from? We said that the responsible in the mass of atom and the molecules or elements are the protons and the neutrons, since they compose the total mass of the atom. But since zinc atom, for example, water and iron, and all of the elements and compounds, they do not have the same number of protons and neutrons. And that's why they do not have the same mass. At this point, we have to say that the molar mass has a great definition, and it says that it is the mass of 1 mole of a compound, of an element, of anything. Okay, if we take 1 mole of iron, of zinc, of water, of any chemical, and just put them in a balance, they won't have the same mass because they have the atoms themselves, they have different number of protons and neutrons, and that's why you won't have the same mass. Where do we get the molar mass from, or how can I calculate it? First of all, you have to put in your mind the periodic table contains a lot of information. Let's take the information of hydrogen atom. If you go to the periodic table and look at the hydrogen atom, actually it contains 2 numbers, let's say 1 above and 1 below, in addition to this number 1.008. This is the total number or the nucleon number, which represent the protons and neutrons. And this number here represents the number of protons. This number here actually represents something called atomic mass. Atomic mass. And actually, if we need to calculate the molar mass in here, we have to go to the periodic table and just look at this number in here. So, for hydrogen, the atomic mass is 1.008. The total number of chlorine atom is 35. The number of protons are equal to 17. And actually, the atomic mass of chlorine atom is 35.45. So this is the number that we have here, which is the atomic mass, and actually it equals to 35.45 gram per mole. So if you go to the periodic table, we're going to have the atomic masses for all of the elements. But how can I calculate the molar mass for, let's say, NaCl? All right, so you got to the periodic table again here. And let's go to the sodium atom. From the periodic table, you can see that the sodium atom has an atomic mass of 23. And then you say we have another atom, which is plus. What is the atomic mass of chlorine? Actually, it's 35.5. And it equals to 58.5. So this is the molar mass of NaCl. Great. If we need to calculate the molar mass of SO3, how can I do it? We will go to the periodic table, and actually the sulfur atom has an atomic mass of 32.1, and then say plus. You can see that you have 3 oxygen atoms. So the atomic mass of oxygen atom, 16, but you have to say times how many oxygen you have? You have 3. And then the answer is equal to 80.1 1 gram per mole for this. Okay, let's take another example. Let's say Mg SO4.7H2O. How can I calculate the molar mass? By the way, the molar mass is abbreviated by MR. So, like, MR represents the molar mass. So, how can I do? The first step is looking at the Mg. From the periodic table, actually, it's equals to 24.3. All right, for sulfur, we can say plus. Sulfur is equal to 32.1. How many oxygen you have here? We have 4 oxygen atoms, and they're multiplied by their atomic masses, and then say plus. What is the meaning of that H2O? Actually, it represents that we have 7 water. The crystallization of water is 7, which means that we have 7 H2O. However, we can represent this by 7 times. What is the molar mass of H2O? If we come to H2O here, actually have 2 hydrogen atoms, 2 times 1.008 plus 16. And actually it equals to 18.016. So this number here is multiplied by 7. So we can take 7H2O, all right, and say like 18.016. And then the answer is equal to 246.5 gram per mole. Let's recap the first law that we started today in this class. And we said that if you want to calculate the moles, we can use this relationship, which is the mass over the molar mass. Okay. All right. So let's say if you want to calculate the moles of 2 grams of water, how can I calculate how many moles do we have in 2 grams of water? We can apply the same rule. We can say that the moles of water are equal to the mass, which is in 2 grams, over what is the molar mass of water? We have 2 hydrogen. We can say 2 times 1.008 plus 16 and equals to 18.0116. And at this point, you can divide it over here, and the answer is equal to 0.111 mole. Let's start practicing on some questions. Read this question carefully. And this is a question we need to calculate the mass of this given number of atoms of iron. So how can I do this? Put in your mind, we can calculate the moles by different methods. All right, so the first method here, once we just remembered that each 1 mole of any, let's say, element, compound contains 6.02 times 10 to the power 23 particles. Or we can calculate the moles by applying the mass over the molar mass, which is MR abbreviated. So how can I calculate the mass? If you need to calculate the mass, we need the MR or the AR, and we need to calculate the moles. Well, how can I calculate the moles? We can find out the ratio in here. All right, so let's apply this ratio. Each 1 mole of any compound, molecule, anything contains 6.02 times 10 to the power 23. Since the iron is a metal, and actually metal appears as atoms, so they're not molecules, okay, then we can say that how many moles of here, I don't know, we put X, I don't know actually, but the number of atoms that are given to us is equal to 6.2. So here we have 6.2 times 10 to the power 23. How can I solve this? We can make cross multiplication, and then we can say here we have X times 6.02 times 10 to the power 23. We multiply them here, equals to 1 mole times 6.2 times 10 to the power 23. By dividing 6.02 times 10 to the power 23, and we do the same thing here, which is 6.02 times 10 to the power 23, then the number of moles, which are X, equal to 1.03 mole of iron. Since we have the number of moles of iron and I need to calculate the mass, we go back again. I have the moles, the AR, and the mass. Now I can do it. So let's apply the rule again. The moles are equal to mass over molar mass. The moles are equal to 1.03. The mass is unknown over the molar mass. Where do you get this molar mass from? Here you are, we have iron. This is the number that we need. It's 55.85. 55.85. And then the mass is equal to, we just make a cross multiplication in here, as we can see, multiply them together, and then the mass is equal to 55.85 times 1.03, and then how many grams we have of iron? 57.52 grams of iron. Let's jump to this question. The question is asking me to determine and to calculate the number of atoms of oxygen. Put in your mind, if they're asking you about the number of atoms, the number of molecules, the number of ions, you have to put in your mind Avogadro's number. And you have to remember this beautiful relationship, which is 1 mole is equal to 6.02 times 10 to the power 23. And at this point, I need to calculate the atoms of oxygen. But what are the given informations? I'm given the grams, which are the mass. So I need to calculate the moles at this point in order to calculate the number of atoms. So how can I change the mass to moles? By dividing over the AR. So at this point, we can say, all right, the moles of oxygen are equal to mass over molar mass. The mass is equal to 0.252 over 16, which is from the periodic table. And then the answer is equal to 0.0158 moles. Here, 0.0158, and then just put X under the number of atoms. Then X equals to 9.48 times 10 to the power 21 atoms. So this is the number of oxygen atoms at this point. How many atoms are in 1 mole of water? What should I do at this point? First of all, you have to look at water molecule. If I ask you, like, each water molecule, how many atoms that contains? It contains 2 hydrogens and 1 oxygen. Then the total number of atoms is equal to 3. But the question is asking me about how many atoms in 1 mole of water. Put in mind, each 1 mole of water contains 6.02 times 10 to the power 23. But this number here represents the number of H2Os that you have. But I need to calculate how many atoms are in 1 mole. So you can say, for water molecule, 1 H2O contains 3 atoms. Each 1 molecule of water contains 3 atoms, but in 1 mole of water, we have this huge number of water molecules. So we can say, here we have 6.02 times 10 to the power 23. And here we have to put X. Then we multiply those numbers together. And then we can say, the number of atoms in each water molecule are equal to 3 times 6.02 times 10 to the power 23. By the way, this 6.02 is the number of water molecules. And here we can say, like, each water molecule contains 3 atoms. We can apply the same relationship here. For example, like, we can apply it to C2H6. If I need to calculate how many atoms in here, we can say we have 2 carbons and 6 oxygens, and the total are 8. So if I ask you, for example, how many atoms are in C2H6, easily you can say each 1 mole of C2H6 contains this number of molecules, right? But after doing this relationship, you have to say another thing, which says each 1 molecule of C2H6 contains 8 atoms. All right, so how many C2H6 you have here? We have 6.02 times 10 to the power 23. And just like do a cross multiplications as well. Sometimes if you need to be, let's say, more specified, I can ask you how many hydrogen atoms. I can say how many hydrogen atoms. You can say like each molecule of C2H6 contains 6 hydrogens. All right. Since you have in each 1 mole of C2H6 this huge number, 602 times 10 to the power 23, then you have to make a cross multiplications and then calculate the number of hydrogen atoms in 1 mole.